your rig, made for your pump rig, made for your drill rig. We don't need to use the same thing. I'm not going to say one thing is better than the other. What I'm going to tell you is, regardless of which one you use, you got to have energy. You've got to put energy in your redevelopment or your rehab to make things work. I can put all the chemical in the world in my dishwasher, all the soap in the world in my dishwasher, but if I don't turn it on, my dishes don't get clean, right? They're not going to get clean. I need energy to make that soap clean them dishes. The same for down well. Down hole, you've got to have energy to make the chemicals work. So physical cleaning, you can do brushing, bailing, surging, swabbing, high pressure jetting, sonar jetting. But regardless of whatever method you do, you need to follow it up by bringing that crap back out of that well. If you leave it in there, it's going to go ahead and continue to plug that well off, and it's going to grow bacteria. Even if you killed the bacteria that's there, now you've got food down there for other bacteria that's going to come. So you've got to get it back out of the well. And don't forget the sump. The sump's one of the most important things to clean. A lot of people, what they'll do, when they're done with a rehab, I shouldn't say done with a rehab because they haven't done it correctly, but when they're done doing their chemical cleaning, they put the permanent pump back in. It might be 100 feet off bottom, it might be 400 feet off bottom. They turn the pump on, they pump the well until the water clears up. And they say they're done. You're not done if you haven't evacuated every foot of that well. You need to run that. If you're going to go back in with a pump, you need to put swabs on it somewhere so you're pumping from a given interval and you're evacuating every part of that well through that pump and get it back out of the ground. And don't put it right back down. Don't put it in a tank and use that same water to pump with. I like nylon brushes better than I do wire brushes for the simple fact a lot of times you can't see behind the buildup that's in the screen, so you don't know how good them screens are. If you go in with a wire brush, you may damage it. There's times I'll go in with a nylon brush first and brush it and see there's still buildup and maybe follow it with a wire brush just to get what I can't get with the nylon brush. But I like to start with a nylon brush. And then after I brush it, I like to airlift it or pump it to get it out. Airlift is to me better than pump because I don't want to destroy the pump. And I don't know what else I might be pumping through it. You look at the different types of screens, they're going to dictate different types of energy needed to get past the damage, to get out through that gravel pack. If you got wire wrap screen, it's pretty easy to get energy into the gravel pack. But again, it's not easy, even with wire wrap, to get it through the gravel pack to the formation. It takes a lot of focused energy. And by focused energy, you'll see what I'm talking about, between two swabs, trying to get that energy to go out instead of just up and down. And I don't want the energy spread out between 200 or 300 feet. It needs to be very focused. The different types of screen there, you can see what the energy's doing as you're giving it a jetting action or swabbing, surging action. Some of it goes down along the gravel pack. The wire wrap, it definitely goes out. Louver's probably the second best because you get more energy out through that than you do a torch slat. But it just depends on what you have. Now, with any of these screens, it's going to be hard to just use a mechanical agitation to clean it because you have dead spots. And with them dead spots, that's where your chemistry comes in. It helps get into them dead spots. You need to understand the well dynamics. How is that well built? What's going on downhole? You've got, if you add the chemistry from the top, where's it going? It's going out in the cleanest zone that you have, probably in the upper part of the formation. It never makes it to bottom. Yes, acid water may be heavier than fresh water, but chances are it'll never get to bottom, and when it does, it's so diluted that it's not going to do any breakdown for you. So you don't want to add your chemistry from the top unless you've only got a 10-foot screen zone or a very small screen zone. And if you're adding it from the top, even when you've got a minimal screen zone, it's good to be agitating while you're adding from the top. But if you've got screen, blank, you're doing your customer a disjustice by adding chemical from the top of the well. You need to trim it from bottom up or up, down, across all them zones. You need to understand, when you're pumping, where's that water coming from? You think a lot of times that when you're pumping, you're moving all that water. Most of the water is coming from wherever your pump is. It's not coming from the top. It's not coming from the bottom. It's coming in laterally at wherever your pump's set. This is the tool I love. This tool, I can place my chemistry. I can pump it down the tubing. It goes out through here. I've got a surge block here or a pack. I don't want to call them packers. They're really not packers, but they're disc that helps, their isolation disc that helps divert the energy out through them holes into the formation. Whoops, what did I do? This from here to here, 5 feet. It could be 5, it could be 10. I've seen it be 20. And you can still be effective depending on your equipment, maybe at 20. It depends on how bad your buildup is. But this one here, I can put my chemistry where I want it. This one's got air coming back in. I can airlift with this, so I can surge the swab, airlift the debris back out of the well with the same tool. So I can create my energy. I can create my instead of adding trimming, I add this to get the chemistry back into the well wherever I want it. And I can evacuate with the same tool so I don't have to trip 3 or 4 times to get the well cleaned. And I've seen these too. Actually, we've had some where we put an electric motor on it, or electric pump downhole and use it. But we've had some failures with that. You hear this kaboom! You got a downhole explosion. You shorted a wire downhole, and it's never fun when you do that. Again, this is another picture of the isolation tool. You can see the airlift. You got your tubing coming down to airlift, or you can have the outside air going in. Just perforated pipe. They're simple to make, simple to build. They work great. When we look at chemical in a well, we're putting that in there because, again, we can't get our energy all the time wherever the plugging's at. So we want to be able to reach that blockage wherever it is. Chemistry helps us reach areas that we can't get physical energy to. It helps dissolve the blockage. And if we use it correctly, if we use it to the manufacturer's recommendation, it avoids damage to that wellbore or to the casing and the tubing, the screen. It avoids all the downhole damage and to the surface equipment. If we use it wrong, if we don't inhibit, we can have damage. And a lot of people think that if we've got stainless steel screen in the hole, I can run hydrochloric acid and I don't have an issue. I've seen lots of stainless steel screen damaged with HCl or hydrochloric acid. So don't think that you're not going to damage it. You can. You'll pit it. It'll look just like if you've got sand erosion or something on it, but it's pitted from the acid real bad. When we look at the chemical dosage, again, you've got to base that on what's going on down the hole. How much mineral do I have or biological matter do I have? If I'm going to put chemistry in a well, I want that chemistry to react with something down there. If I don't have calcium carbonate or some kind of iron buildup, I probably don't need to put acid in the well. I may just need to put something that'll kill the bacteria in the well. So you've got to know what it is you're fighting. Do we treat all wells the same? I think I just answered that. Marvin, do we treat all wells the same? Of course. Okay, so cookie cutter, we're going to put this much in every well. No, we don't. We don't treat all wells the same. We got to know what that problem is. What is it that we're trying to treat? A well is just like the patient, and you're the doctor. Okay? So a well is basically a living thing. It's got a lot of things happening to it. It's evolving over time, and we've got to try to get it back to its original condition. We want it healthy. We want to keep that well healthy. So we're going to determine that by that water analysis, by past success, through a visual observation. I put WSE down here. That's Water Systems Engineering. I like them. You don't have to use Water Systems Engineering, but have some lab, have somebody you can fall back on when you get into a problem. You may know your area, but when you step out of your area to a new area, you're not going to know what that problem is, most likely. Have somebody you can send a water sample to help you, guide you through that process, whatever that process might be. We have a lot of choices when it comes to chemistry. We've got Johnson Chemical, Cody Chemical, Well Clean, Baroid, Jet Lube, Lane, Aquafreed, and there's numerous other ones out there. 95% of them are good. I'm not going to name the bad ones, but 95% of them are good. If they know what the problem is, they can give you a recommendation of how to fix it. But you have to give them the correct information so they know what the problem is. You need to collect a water sample for them, show them some downhole videos, give them as much information as you can so they can formulate a recipe for that specific well. Almost all these, or I should say all of these up here, will work with their guidance, or they wouldn't be in business today. Oops. But the treatment is going to vary by the type and the severity of the problem. Again, is it going to be a simple disinfection, or is it going to be a total rehab? Do I need to pull the pump, or can I do it with the pump in the ground? Do I need to have that well offline for a week, or can I do it in a day? You know, it's money. Money talks, and you need to relay that. You need to communicate whatever the method's going to be to the well owner, you know, to your customer. You need to understand the type of fouling. Is it mineral, biological, or is it fines migration? Or drilling mud left in the hole? It's going to vary by the well size and type. You can't treat a 30-inch well 1,000 foot deep the same as you do a 6-inch well 200 foot deep. It's going to be totally different. So volumes are going to be necessary to dictate what kind of chemistry. Then your neutralization potential, your water column, and your deposits. Different chemistry downhole is going to neutralize some of the acid. If you got calcium carbonate down there and you hit it with acid, pretty soon that 1 pH that you put down there turns into a 3. It turns into a 4. Well, at 4, it quits working. The pH of soda pop is 3. Of your Coke, that's about a 3 pH. But at that point, it quits dissolving any more minerals. So you got to keep that pH driven down with more acid. So you want to know what you have down there. What are you combating? What kind of a percent of material are you going to put in the well? It's going to vary by the integrity of the well. If I got screen that is already decomposing, I've got some holes in it, I may be afraid to put acid down there because I may make it even worse. You know, especially if I put HCl down there, because HCl is a fast-acting, more aggressive acid. It can have more of a detrimental effect on the well screen and casing than a phosphoric acid. I'm going to look at my site constraints. Where am I going to go with this material when I bring it back out of the ground? Do I have a field I can pump it on? What's Jerry going to say about that? Do I have a municipal offloading site or something that I can haul it to or pump it to? I mean, all these are going to be factors that go into how I'm going to treat that well. But I want to choose something that's going to target the problem. It needs to be NSF approved, National Sanitation Foundation approved to put it in a drinking water well. And I don't want to just say a drinking water well because most stock wells are what? They're pretty close to a drinking water well, right? A lot of them are within the same vicinity as the drinking water well or municipal well. And whatever you do in that stock well can have an effect on neighboring wells. So you want to be careful, even though the rule says domestic or municipal wells have to have everything NSF, it should be all wells. So just because it doesn't say it in the rule doesn't mean it shouldn't be in the rule, because it should be. Look at NSF material, because they're designed to go into a drinking water well. And again, stock well may be influencing in drinking water well. You're going to look at what's going to complement the treatment method. You don't want any detrimental effects to your tubing. And you want to have something that you can manage the pump off when you bring it back out of the well. You can't bring strong acid back and pump it underground. You want to be neutralized when you bring it back out. And one of them companies up there, they say you can neutralize downhole. Don't neutralize downhole. If you neutralize downhole, you're leaving the chemistry in the well. You're not getting it out. So always neutralize after you bring the fluid out to a tank and then dispose of it per the state rules and regs or the local rules and regs. Acids generally operate at a depressed below 3 pH. When you put them down the well, you normally put them down about a 1 pH. So you mix your solution at the surface to about a 1 pH level, and then you put it down the well. They're going to vary by weight, concentrations. Some acids are weak, some acids are strong. Hydrochloric is about 1/3 the strength of phosphoric. But it's fast reacting, and it can burn you, where phosphoric is much more forgiving. If you get it on you, you've got time to go get it washed off without any injury. So evaluate the quality and request a certificate, too, on your acids. Again, if you're using an NSF acid, it's a clean acid. If for some reason you can't get an NSF acid, there's a lot of tech-grade acids out there. They're very dirty acids, and you want to try to shy away from them. They're probably not going to give you chemical analysis of that bad acid because they know that then you're probably going to refuse it. So if they're having a hard time getting you a breakdown of the certificate of analysis, shy away from that acid. Use a rate that will affect or treat the problem, and then make sure you neutralize it once you get it back out of the ground. Common acids: hydrochloric, sulfamic, phosphoric, oxalic, and hydroxyacetic. These are the most common acids used in water well treatment. And these are some of the characteristics. I'm going to try to make these slides available to you through Robin after the presentation if you want to come back and get some of these charts. Because this is a great chart for you guys to have if you're doing well rehabilitation. Because if you look at it, corrosiveness to metals and skin, severe. But I want to use something that's really severe to the skin. If I get it on me, it's going to burn me. If I get it on my employees, they're probably going to sue me, right? So I want to use something that's not going to be as detrimental to my employees, but I want something that's going to work good for whatever the problem is downhole. And so there's a lot of information right on this chart, and I'm not going to take time to go through it all, but it's worth its weight in gold. I use it all the time when I'm doing acid treatments. Hydrochloric is normally used in the range of 1 to 12%. Typically 8 is an average. It's a single bond, so it's a very fast-acting acid. It comes in a variety of different names. It's very aggressive, though, to metals, even your stainless steel, and even more aggressive to your skin. You get it on you, it'll burn you. It requires an inhibitor. If you're going to put it in the well, don't just ask for an inhibit acid, because an inhibited acid is not sufficient for our water wells. The oil field puts it in, they leave it across the formation for just a matter of about an hour or so, and they pump it away. We're leaving it in there for a couple days. If we do that, it'll eat up your casing and your screen. So you want to add additional inhibitors. And almost all your rehab chemical suppliers have acid inhibitors that you can use to inhibit your casing and screen. Phosphoric I like better than I do HCl in most cases. It's a slower acting acid. It'll dissolve more calcium carbonate than HCl. It's stronger. It's 75% instead of 30% or 28% as the hydrochloric is. So it requires less acid to make up the same volume. It's not aggressive toward metals. It's less aggressive toward skin. Average range, 3 to 10%. Again, average is really about 8. This is another chart that'd be handy for you guys to have. I probably should have printed a couple of these off and just given it to you. But this one is acid volume needed per 100 gallons of solution for whatever percent you're trying to get from 1% to 20, depending on the strength of the acid. Phosphoric comes in 75, 80, and 85% concentrations. So I think this next slide, if I still got it in here, this one here, if I wanted to go with an 8% solution, phosphoric, if I'm using 85%, I need 5.8 gallons per 100 gallons of solution. If I go with the hydrochloric, 31% is the most easy to get your hands on. I need 23 gallons versus 5.8 gallons. So when I'm doing a large job, that's going to dictate how much I have to take out there. What kind of equipment am I going to need to haul it out there? Because I may need several totes of hydrochloric, and I might only need one of phosphoric. If you look at, again, this chart here basically just goes in. It's comparing hydrochloric to phosphoric. A well that needs 1,106 gallons of hydrochloric only needs 383 gallons of phosphoric. So 1,106 gallons of one, and this is just going to an 8% solution, 383 of the other. So which one's cheaper? If I have to add more hydrochloric, is that going to be more expensive than adding less phosphoric? The answer is no. But everything else down here is the same. It's going to take the same amount of dispersant, same amount of inhibitor, and I shouldn't say dispersant. The W400 is actually like a soap to get it back into the formation farther. Your dispersant, it's going to take 115 gallons on each scenario, 15 gallons of clay dispersant. You know, everything's the same except for the amount of acid. Phosphoric acid costs 3 times as much as hydrochloric. So, but I need 3 times as much of it, of the hydrochloric than I do phosphoric, so the cost is the same. It's just basically the transportation, and then with the phosphoric, you don't have near the skin damage. It takes a little bit longer to use. So if you've got water moving in the well, if your water is not staying in the well body, you may want to go with the hydrochloric because I need more time for the phosphoric. But if you don't have water migration, the phosphoric will actually do a better job cleaning than hydrochloric. Again, this is basically the same thing, just 3.5 times, 3 to 3.5 times more HCl than phosphoric. So that's just what we just talked about. Okay, the other thing we got to think about when we put acid in a well, or doing a chemical rehabilitation, is if I just put it in the well, what's happening to that chemical? Well, what it's doing, it's plating out. You put the acid in, it comes up, it starts dissolving the mineral buildup. And as it dissolves the mineral buildup, it neutralizes itself. It's spending itself. So I have to have energy. I have to have energy to keep moving that acid around to get new acid against that mineral buildup, to keep it dissolving. Because when I say it spends itself, it's got up in here we got a 1 pH. Here at the interface it turns into like a 3 or a 4 or a 5 pH without any movement. And so it's not effective. So I got to keep that 1 or 2 pH at the face of whatever I'm trying to dissolve until it's completely dissolved. Polymer dispersants actually help too, because when we put the polymer dispersants in with our acid, now I'm able to hold that much more dissolved minerals and biofilm within the fluid within the well without it reprecipitating back out. So if you think about salt, 189,000 parts per million chlorides gets you to saturation point. Anything more than that, it falls out. Well, calcium does the same thing. So once I get so much calcium in the system, it's going to start reprecipitating. It's going to start forming again back on the well body, in the formation, down at the bottom of the well. I want to keep it in solution. So if I add a polymer dispersant, I can put 3 to 5 times as much dissolved minerals in that fluid and keep it in suspension so that I can bring it back out of the well. So I don't want to go in with just an acid. I want to go in with something to make that acid work even that much more for me. So it's designed to prevent that precipitation of dissolved ions. But whatever you use, it needs to be an NSF dispersant. You put a surfactant in. The surfactant is actually a wetting. It helps get that chemistry farther back into the well. So let's look at the blockage. Our blockage can be physical, so it can be drilling debris, incomplete development, silt, or clay migration. It can be chemical, it can be mineral precipitation, it could be iron, it could be calcium, magnesium, several things, or it can be biological. If it's biological, you've got biofilm, but you don't have anything mixed within that biofilm. I'm going to treat these all different. If I just got biological, again, I don't really need much acid to break down biological. And I definitely don't need a mineral acid because I don't have any minerals in there. So I'm going to use an organic acid to help break down that biofilm at a very low concentration, probably. Have very minimal effect on any of the downhole equipment that I've got. So again, you've got to know what that blockage consists of. Even a lot of our wells that we know we've got mineral buildup and biological buildup, I still like to go in with a mud and clay dispersant as one of my final steps to help redevelop that well. I want to move some more fines if I can out of that well. Some of the clays that might have been pulled in toward that gravel pack, I want to pull them farther through and try to get that well back to that original state, whatever that efficiency level was when it was new. And if I follow it with a clay dispersant, following my well rehab, generally I can improve that well another 5 or 10% of well efficiency. I want to increase that well efficiency. This is what your congestion looks like. You've got all different kinds of things within your kettle or your well, in the well. It's very congested. Again, we want that dispersant in there to keep them apart so they don't precipitate. Keep them in suspension, get them removed from the well. Again, I said this already once. Don't put don't put the permanent pump back in and set it in a given spot and try to evacuate the well, because you're not evacuating the well. You're evacuating the most prolific area, probably closest to the pump. But you need to evacuate all that debris out of the well from top to bottom. And you can tell when that's done. If you start at the top, get that one to where it's neutral and you don't have any turbidity or buildup, and your pH is back to your base. Move down, do it again, move down, do it again, move down, do it again. until you're all done. And then you might even pull back up and check 2 or 3 places to make sure you got it all. But you want to get it all back out of there. Number one reasons for poor results is what I just said right there. Pumping or airlifting, you need to evacuate that fluid from the well. From all the well. All the screen. And something else I see a lot of people do, and they do, some of them do a damn good job getting it cleaned out of the well screen, but what they didn't do, they didn't evacuate the blank. They never pumped the acid and the solution out of the blank casing. Because you can pump all you want from down in the screen interval. If you've got a well that produces more than the pump will go ahead and pump, and you're not drawing that water level down. So that water level now has acid and minerals and decayed matter and everything up there in that blank. You need to force that down into the pump. Displace that fluid up there down to the pump while you're pumping to get that area cleaned up too. Follow me? The volume that you're going to treat you need to get out here into the gravel pack, not just, I should say, out in the formation, not just the gravel pack. So we need to calculate what that treatment volume is going to be. And we're not just treating inside the casing, because if we treat inside the casing, we're not doing anything outside the casing. If we put just enough in, say I got a 12-inch casing, and I need 144 barrels of treatment per 1,000 feet, well, that's not doing enough to get out here in the formation. So we need to know what that volume is, and we want to go 1.5 to 2 times the static well volume. Now, there's instances you're going to change that because your static well volume might be 1,000 foot of blank, and you only got 30 foot of screen in there. So really, you only need to treat the formation on 30 feet, so I don't need to go 1.5 times for the whole well. So that 1.5 times for that 30-foot interval, and then whatever the cased hole volume, not the screened volume, is. You always want to treat the blank as well as the screen, okay? Check your equipment. Make sure you don't have any leaks. Check your injection system before you put acid in it. Always add water to the tank first, and then add your chemistry to your water. Don't add water to your acid. Do site modifications before you put your chemistry, before you mix your chemistry. Make sure your tooling will go down hole. I've been on several jobs where we thought we had an 8-inch well or a 12-inch well, and we couldn't get in with the equipment that we were going to use because either there was a reduction inside the well or there was something left in the well, some tubing or something left in there, and we couldn't get by it. So check things out before you mix your chemistry up. Proceed when you're ready, and not before. Mixing chemistry, got to be safe, goggles, gloves, PPE, and a wash area. You notice he doesn't have very much of that stuff on. It's not the safest way to mix because he's got short sleeves. So if he gets acid on him, he can get burnt pretty good. But you want to have a wash area off where if he does get it on him, he can go get it washed off. Don't go out with a 5-gallon bucket to wash off with. Have enough water to dissolve or dilute all that acid that you get on you. Be accurate. Verify your volumes. Verify your mix percentages. And then add this accordingly down the hole. I already said this. Mix acid into water first. Mix the dispersant and acid mixture after that. Mix your surfactants last. Your surfactants are going to foam on you, so you want to get them in the system at the very end. Some tanks or some jobs you're going to need large tanks depending on the acid volume you got to put in. I just did one the other day that was 30-some thousand gallons of 15%. So, pretty good sized job. And we had frac tanks like this for the chemistry. Use a double surge block to get it placed where you want it. have agitation to agitate it to help keep that acid working while it's down the hole. Displace the fluid into the formation. Again, the more focused that energy, like through a 5-foot double surge block, the better the success. The more energy you can give it, the better your success is always going to be. Huh? No. Sorry, I'm blocking your view too. Movement of the chemistry into clogged areas is very important. You got to get it in there. Monitor your activity. Check that pH of your solution downhole as much as you can. Check it frequently. If you got over a 3, it's probably not working for you. You know, you can check it on the top of your baler. You can send a thief down there, something. Don't send one of your hands, though. But you can send something downhole to check that pH. Bring it back up. Know what it is. Because if your pH rises, you're just wasting time and energy and money. Check that TDS. You can do that, definitely when you're bringing it back out. You want to know that your TDS is back to whatever it was before you started. That's a good indicator because a lot of times the water looks clear, but it's full of dissolved solids. You haven't got them out of the hole. Your pH may be neutral, but your total dissolved solids is really high. And if you leave them down there, they're going to reprecipitate. You're going to see color changes, odors, foaming, all different kinds of things when you're bringing this back out. Contact time, 5 minutes. Contact time, generally 24 to 48 hours is what you want your acid solution or your cleaning solution left in the well for. But that's going to depend on what kind of inhibitors you're using in there and what you have downhole. What is the problem? How severe is it? The severity will help dictate that. Certain things are slower to react than others. And just like in the mud class, use these pH papers. They're simple, easy to operate. Check to make sure you're down in that purple area on the bottom. Because once you lose that purple color in the bottom, you're above 3. Your acid's not doing anything for you. You're going to put it in at 1. You're going to do your job between 1 and 3. You're going to bring it out. If you get to a 4, get it out of the hole or put some more acid back in there, one or the other. And then we want to bring it back out until we got a 6.5 to 9, and then we can discharge it. Or it depends on what the state rules, regs, and local regulations are. Some places I can't discharge at all, but some places I can once I have it neutralized. So you got to look at these disposal issues. How much volume, how much equipment is needed, and what kind of neutralization. Understand what your regulations and your compliance is. We've already talked about that. It might require temporary holding tanks. We've had jobs where we've had to line up 10 to 12 frac tanks to pump this acid into because we were pumping at a high rate, and we didn't have time to neutralize until it got to the tanks. And then once the rig was putting the pump back in, then we started neutralizing our acid tanks and disposing of it. Your discharge or your rehab pump is just the regular pump. Generally, I like to use one that may have a little bit of wear because I may have some debris coming through it. I don't want to waste or spend a lot of money repairing a pump, so I'm just going to get one that still works decently and put it in, use it as my rehab pump. But you want it sized for rapid evacuation. If it's pumping too slow, it's going to take days to get all that chemistry back out of the well. So you want to overpump that well if you can. Pump more volume than what the well will produce. Use something that's chemical tolerant. Like I said, we already talked about that. Know what permits are required. The discharge is going to have color in it and odor. We can neutralize with lime, soda ash, caustic soda, or caustic beads, either liquid or powder. Again, you've got a lot of chemistry there. Get it out of the well. TDS meter. At what point are we satisfied? That's a good question for you. At what point are you satisfied that you've done a good job for your customer? You want to make sure your TDS is back to normal, and you should know what your baseline was when you started and try to get back to it. And then after all that, go in and chlorinate your well, kill the bacteria. Because just because I went ahead and put acid in the well, I never killed anything. So after that well rehab, go back in and chlorinate the well, disinfect everything down there, kill all that bacteria. Do I need to stop right here? I can stop. I can stop right here, because this is a good place to stop. Anybody got any questions on what I talked about? I know I went over it really fast. There's a lot involved in well rehabilitation. You know, we can't see downhole, so we have to take everything that we can as a tool to determine what's happening, and then we need to monitor it as we're going. And then we need to record what we did so that the next person that comes onto that well knows what you did and when you did it. Questions? I am. Yes, that's a good question. When we're calculating what volume and concentration we want to put downhole, we need to take into account there's already a volume within that well body. So if I want to end up with a 8% solution, I'm not going to mix my total well volume at surface. I'm going to mix well volume, and if say I want 100 barrels or 100 say I want 100 gallons. If there's 10 gallons in the well, I'm only going to mix 90 here. I got 10 gallons in the well, and make my 100. But I'm going to put enough chemistry in for the 100 gallons. Total volume. So if it's gravel packed or not gravel packed, it's going to make a difference. If it's a gravel packed well, my volume's 40% out in that gravel pack, plus the casing volume. So I'm taking that whole volume and using that as part of my treatment volume, plus my mixture that I got to put on surface. So when you do your volume count the casing, count the formation. Typically I'll go 1.5 times on the formation, but not on the casing. And then mix enough chemistry for that, plus what I need up on top. When I say up on top, you know, if it's all screened, you're going to go 1.5 times that well volume. So you might only mix 1/3 of your solution in the tank, and the rest of it's already downhole.